Hi, everyone, and thank you for joining us today for our Johns Manville Making the Most of Offsite Construction webinar. I'm Natalie Carney, and I will be your moderator for today's presentation. Before we dive into introductions, I would like to go over a few logistics. If you have any questions or concerns throughout the webinar, you may submit them at any point during the presentation via the Q&A or chat feature at the bottom of your screen. We will address these questions live at the end of the presentation. Also, just a quick disclaimer, the information provided in this webinar is to not be used as a substitute for professional engineering design and/or documents required by building code, contract, or law. Please refer to the manufacturer's specific application guides. Additionally, we'll follow the webinar today with a survey. This is your opportunity to provide us with feedback on how we did today, ask any additional questions you may have about the topic of the webinar, or suggest new topics for webinars you'd like to hear in the future. We are continuously striving to improve and evolve our webinars, so if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like we've missed the mark today, we'd encourage you to fill out the survey. We use your feedback to improve our webinars and provide the information that has the most value to you. Also, we do post a recording of it online for you to watch at your convenience or share with your colleagues. And with that, we'll dive into some introductions. Joining me today is Dwight Stone and Jerry Fox. Dwight, could you start us off with an introduction and then we'll follow with Jerry?
Sure, thank you, Natalie. My name is Dwight Stone. I'm the building enclosure consultant for Johns Manville. I've spent about 8 years here at Johns Manville, both in the building insulation side as well as the roofing side. And prior to that, about 20 years in the architectural field, both in project management as well as specification development. So kind of a well-rounded view of the field. I'm actually based in Denver, a little south of Denver in a little town called Larkspur. And I'm looking forward to talking about offsite construction today. Jerry?
Thanks, Dwight, and good afternoon, everyone. Thank you for joining us. My name is Jerry Fox. I'm a regional builder specialist, registered architect, and a lead GA. I am been with Johns Manville for almost 10 years now, based out of Charleston, South Carolina. I work with offsite construction companies, engineers, and architects to offer solutions for projects being built in factories that need to meet specific design criteria, such as fire resistance, sound attenuation, vapor and air barriers, and of course, energy savings. Here at Johns Manville, we focus on providing solutions that offer time savings, waste reduction, and suggest the most economical approach to reach desired attributes for our installed materials. So we'll get started today in the presentation. Just a little housekeeping here. Johns Manville is a registered provider with the AIA Continuing Education System. This presentation is an approved AIA course, and will offer one learning unit, or HSW hour, for those AIA members who provide their registration information via the QR code here on the screen, or by logging on to the link, which will be posted in the chat feature. This credit for this course will be posted for AIA members shortly after the completion of the presentation, and the certificates of completion will be distributed to all attendees who provide their information with either of these options for registration. So as an overview today, we're going to cover the history of modular construction, review a little bit of the market data, and discover some of the driving forces that are making this an attraction to the construction industry. Review design for modular construction, also look at benefits of modular. We'll cover some design considerations, and then towards the end, we're going to also talk about some of the solutions that Johns Manville has evolved over the last few years here to help, and then cover some additional resources as well. The modular or offsite construction has been around since the early Industrial Revolution. Let's take a look at the history of offsite construction in the United States. Modular construction follows economic booms. The first one in the U.S. was the gold rush, following the discovery of gold in the western United States. Pre-cut materials were delivered to pioneers by the new rail lines to assemble on site. Second notable boom occurred in the post-World War housing. After World War I, Sears and Roebuck offered multiple pre-cut material packages for designs that could be selected from their catalogs. After World War II, the actual off-site fabrication or industrial manufacturing of house walls and components began to occur. Also during the 1950s, elements of schools and hospitals began to be built off-site and assembled on-site. You can see the repetitive units that encouraged this approach. In the 1960s, we saw a boom in motel and hotel construction, marking the entry into the multifamily market that we see today. A lull in construction and innovation occurred in the 1990s, which saw industrial concepts applied to the boom in higher density multifamily developments as well. In addition to multifamily, commercial and government construction benefited from efficiencies of speed of modular construction. FEMA attempted to implement en masse after the Katrina disaster in 2006 with some success. All the previous options are on the table at the moment, from large-scale development assemblies with lightning speed to tiny homes available online from retailers. And as we can see, back in about 100 years ago, we had the capability of ordering from a catalog an assembly or a package to build a home. And it's very similar today because we have the internet which we can actually order even small tiny homes via internet. So we're kind of making full circle. It's not new to our environment here. So let's take a quick look at the market share of offsite construction and review the driving forces of why construction method is gaining its attention. There are several modular classifications in today's market. The first is an example of panelized assemblies, which are offsite factory walls, floors, and roof concepts. One example of volumetric construction was made up of shipping containers. This is a popular delivery method for coffee shops, restaurants, temporary emergency response units, and residential. Next is considered relocatable units. Don't mistake these for manufactured homes, as these modular buildings are used for commercial applications for school classrooms, medical centers, office complexes, and the familiar job site trailers. Finally, we have permanent modular buildings, which serve a wide range of uses for multifamily, hospitals, hotels, office complexes, and of course, single-family units, just to name a few. A current look at the market share. When we include all aspects of offsite construction, the U.S. market share in 2020 was estimated to be at about $27.5 billion. Permanent modular construction is one of the fastest growing segments in the modular industry. Although between 2020 and 2021, permanent modular was expected to only grow 5 to 6%. The reality is the value of permanent modular construction grew almost 20%. As you can see in this chart, permanent modular construction market share has doubled in the past 5 years, and it is anticipated that it will double again in the next 5. So let's take a look at a quick case study. Each of these case studies has its own lessons for its stakeholders. Carmel Place in New York City was New York City's first micro apartment building. The 9-story building includes 55 micro units as well as a gym, lounge, roof terrace, and garden, and was the first multi-unit building in Manhattan to be built entirely out of modular components constructed off-site. The building was made up of 65 individual self-supporting steel frame modules 55 apartment units, and 10 core elements. MEPs were installed off-site, and appliances and interior finishes were installed on-site. The design team reported that it was a significant benefit to have a factory located nearby. This allowed for weekly visits during the manufacturing process, giving the team the ability to catch and prevent costs and mistakes, and supported the increase of communication required for modular construction projects. The Vancouver Affordable Housing Agency provides the use of current vacant public land for temporary modular housing developments. These projects are guaranteed to use the land for at least 3 years, after which time they can be disassembled and relocated when the land is needed for a more permanent use. The initial demonstration of this concept is 2020 Terminal Avenue, and this includes 40 units with a shared laundry facility and amenity space. The building is designed to be relocatable with minimal alterations to the exterior, including multi-point foundation system. The Vancouver Affordable Housing Agency reported that the development approval process was overly complex and time-consuming on the initial project, and this gave an opportunity to erode some of the benefits of the modular construction. Today, most of the processes have been streamlined to assist with building code inspections in the factory. It's highly suggested that early engagement with the local building jurisdiction is key, especially if they're not as familiar with offsite construction practices. So what's behind the increasing adoption of modular? Here are a few primary factors driving this adoption. As we all know and we've heard in the past, there's a huge shortage of skilled labor that actually show up on site to build construction projects. It's going to be becoming worse because 41% of the skilled labor force that we have intact today will be retiring by 2031. We consistently in our profession see pressure from our owners and developers and our stakeholders who want to reduce the production schedule and also minimize costs on the site. With modular construction, there's a huge advantage here because as you see in the illustration to the right, everything is built indoors in the factory. So this allows for a smoother operation and a climate-controlled environment for this production line to continue no matter what the environment holds for us outside. There's also improving technology that continues to evolve in this industry, not only in automation steps in the process to help reduce the amount of labor, but we're seeing the technology of building science also being introduced into this industry as well. On-site risk, obviously, if we're able to build an entire building inside of a factory, we can reduce the risk and reduce our concerns as well. This also allows for greater quality control. So we have the opportunity to build higher quality buildings, which kind of bashes the myth of off-site construction being cheap and not very nice quality. Actually, that's just the opposite. And economic factors are making it more viable as well. The cost and speed are primary considerations. As we've all also heard, housing shortages and the lack of affordable housing in our nation and across the globe is a huge issue for all of us. Obviously, with offsite construction, the benefits here are shorter delivery times. What that means for our clients or our customers, and that being the developers, the builders, and the owners, is that they're able to occupy their buildings faster, which then turn, if it were a rental property, would then begin to allow cash flow to become faster and to the equation. Also reduces the financial burden of financing a construction project. Public sectors in most major cities, we've labeled London and New York obviously as two large metropolitan areas that need as much help in the public sector as possible. But this is going across the nation. This is affecting everyone across the nation. Cities like San Francisco, Seattle, Vancouver, and I'll even add Austin, Texas in this as well, are all considering modular solutions to help with the homeless population and providing shelters for the homeless population. Also, they're looking at options to help with the lower middle income to provide affordable housing as well. I'm going to turn it over to Dwight to cover design for modular construction.
Okay, thank you, Jerry. Let's now take a look at how offsite construction does affect design decisions. Okay. So, modular construction is actually scalable. It can be delivered in large or smaller units. The largest available is called volumetric sizing, as we see in the graphic there. These are fully formed structural units that can be assembled to form the larger structure. They're frequently self-contained. They'll probably have their own waterproofing installed. They'll be structurally, have structural integrity so they can be stacked, and they're supporting the structure above. They're transported by truck and craned into place. They may be weatherproofed individually and on site. They will be weatherproofed on site, and hopefully they're weatherproofed on the way out there too. They contribute to the structure of the building and can also form the building core. So you can form stair cores and whatnot out of these stacked structural units. Panelized units actually form building volumes on site after assembly. So the core of the building is pre-built, and probably, due to simply the design, the program of the building is driving that, the approach towards panelization. You'll have the structure already built on site, and then you'll add the panelization to form the building enclosure. They can simply be framed walls, floors, or roofs, or more complex exterior cladding assemblies, complete with electrical, plumbing, and HVAC systems inside for on-site connection. Waterproofing is also a portion of that panelization process. So panelized systems are actually easier to transport. As you can see here on the truck bed, you can load a bunch of the panelized systems on top of one truck bed and have better efficiencies of transportation. But there are more effort to assemble on site in order to form the volumes of the building. More companies can do this from a technical standpoint, from GCs to manufacturers themselves who do the assembly. Less engineering may be involved to design and construct the panelized assemblies, but weatherproofing can actually take longer to achieve, leaving the building open to elements in the process. Volumetric assemblies, however, require more engineering and design up front, but less time to assemble and weatherproof on site. There are transportation limitations, of course, the height, the width, what types of bridges you're going underneath, and whether you need to move any electrical lines, that sort of thing. There will also be a need for a designated area for staging prior to assembly as well. You can't just pick them off the truck and put them on the building. You have to stage them properly, and that takes space and logistics planning. So let's take another look at a successful project here. This is a case study for the Heart and Orthopedic Center at the Miami Valley Hospital. After initially considering volumetric construction of patient rooms as volumes, cost and efficiency in their pre-planning study indicated it would be better to break up each room into 4 modules. The bathroom, the head wall, foot wall, the casework, and the overhead MEP racks. So the GC located a vacant warehouse about 3 miles from the project site to build the custom components. A mock-up of the bathroom module was built in the warehouse for hospital staff to experience and critique. The bathroom pods and dividing wall components were then assembled into a single patient room. And then assembled into single patient room blades so that several would actually fit on a flatbed truck for transport. Assembly did require BIM level precision and early subcontractor involvement to coordinate. Ultimately, the use of prefabricated components reduced the construction schedule by 2 months and reduced the building cost by about 2%. So that's success in the offsite construction world. One thing to note here is the offsite fabrication and transport and on-site assembly were by Skanska, which is operating as the on-site stitch and fix GC. And so this was, as they transported the components out there, the manufacturer, there was no actual manufacturer. The GC was basically just prefabricated those components in a warehouse as kind of a shop fabrication assembly facility. So interesting element to this case study. So there are 2 design delivery models that work with offsite construction. The first is actually the traditional process. The architectural and engineering team designs the project. The GC contracts and builds the structure. The manufacturer provides components that insert into that structure. So the manufacturer is actually acting as a subcontractor in this design delivery model. The second model raises the manufacturer more to the design build GC role, with the architect acting as the design lead and the engineering and construction performed by the manufacturer. Another GC could actually assume the risk of the project management, final assembly, and weatherproofing. So in that case, there would be 3 parties to the construction of that project. So it's important to look at the different delivery methods and what is the most proper one or appropriate one to manage risk during that process. So whatever the risk profile, modular principles can be applied to nearly any construction type except heavy timber. Pre-construction percentage can range up to 95% of the work. Each project has an optimum level of pre-construction that is determined by multiple factors shown here, including labor rates, contractor availability on the site, whether or not you have manufacturers that you can bring on board early or you have to bring them on board later, and then of course, site and financing conditions. So whatever the percentage chosen, offsite construction has multiple benefits, and the right balance is determined by the capabilities of the team and the characteristics of each project. It's an examination. You have to look at the entire process and what is the best way to perform that process. Once you get to the end, the project is done, but really the savings is up to choosing the optimum process. So the ultimate goal is to speed up the construction process and streamline it as well. Design for manufacturing and assembly is actually a defined engineering process. The definition is right up here. I'll read it for you. It's an engineering-based definition produced by Siemens. But DFMA is an engineering methodology that focuses on reducing time to market and total production costs by prioritizing both the ease of manufacture for the product's parts and the simplified assembly of those parts into the final product, all during the early design phases of the product life cycle. To quote Elon Musk, when he was being interviewed by Joe Rogan, he said that the problem is not with innovation or design, the problem is with manufacturing. So once you figure out that piece, the rest of it can flow smoothly. Once the building components are actually designed, it's time to put them together. Since this occurs indoors, there's no need to protect the finishes from the elements, so they can be built the easy way, which is from the inside out. Think about the process. If you're building on site, you've got to create that weather enclosure first, basically dry it in, and then you can begin to heat the interior, put the elements together, put those expensive finishes on. If you're in a warehouse, that enclosure is already constructed. You can start with, carrying the drywall panels inside, build those interior walls, and then eventually finish out on the exterior. So we looked at the process of modular design and construction. Let's look at some of the reasons to consider this approach. These reasons can be summarized in 3 concepts. One is the quality of the product that's produced. Production in a controlled storage, controlled setting is obviously going to be less exposed to the elements and will generally have better, higher quality. Another element to the quality is there's actually more materials produced with used in a volumetric design, because you actually have to create each one of those units as a structure. So they're more significant and more solid when they are delivered on site. Productivity during the process. Workflow is much more easy to plan rather than having people running around a sort of messy project site. You can coordinate those movements a lot more efficiently in a warehouse. And also shortening of the production schedule. This is a big selling point for developers, people looking at the financing side. The construction phase actually gets shortened, as we see on the right here. See that missing, that dashed yellow line, that is the savings of that construction schedule. And what actually leads to that, if we walk through that graphic, the site-built versus modular approach. Site-built, the design and engineering, getting up to the permits and approvals, those can take about the same time, a little bit longer on the design side. And then as you move over into the construction side, the piece that can be done at the same time is concurrent construction. You can build the site as well as build the modules to be assembled on site at the same time. So that leads to that, up to a 30% savings in terms of project schedule. So note, it's not necessarily saving on design time. So cost efficiency is achieved through waste reduction of the construction process will be partially offset by frame and set materials and logistics. So trucking, crane, rental, etc. Reduction of waste and increased envelope performance can further the project's sustainability goals. Also, in terms of adaptability, end-of-life calculations can be positively affected with the potential to disassemble and reuse the building on another site, like we've seen in some of the case studies. So let's look at a project designed with those goals in mind. This is a case study for the Harvard University Pagliuca Life Lab. It was designed to meet the need for specialized laboratory space for startups. The building includes a ground floor of business office space and a second floor of lab space. The university chose modular construction or offsite construction to build as quickly and cost effectively as possible. It was ultimately completed in 7 months of construction, 5 months less than their on-site construction scheduling indicated. This limited the on-campus disruption and allowed for later relocation to a more permanent site in 5 to 10 years, as was their plan. The building is composed of 34 modules, constructed off-site over a period of 2 months to 85% completion. They were steel framed with pre-poured concrete and composite steel deck with finishes, MEP, and cladding system attached. The type of assembly actually encouraged the use of static production methods, which meant the modules were worked on by the various trades simultaneously in place rather than sequentially, as with the assembly line method of production. In some of the photos you've seen kind of rail tracks moving down the lines. You also have these air lifting method that basically uses 100 psi of air to move modules from one side to another of the factory. That was not used in this method due to the weight of the units with the concrete. So the entire building was temporarily assembled in the factory as a performance mock-up prior to transport to the project site. This gave the owner and the architect the opportunity to perform a preliminary walkthrough to address any issues, as well as witness inspections and testing. So what are some barriers to modular construction? Why doesn't everybody do it? Well, of course, there are limitations to design. Not all projects have design time or budget to achieve the level of customization necessary for the specific program of their building. The best manufactured products or modular products have repeated elements that are well, I mean, let's qualify that. So the most obvious savings that you get are in terms of cost and construction time. So that really leads to multifamily projects being some of the more common projects that are used, and they have repeatable elements, and they are can generally be affordable or they can be high end. It really doesn't, there's no qualification there. But one thing you don't see a lot of is customization. It's possible to make the business model work with customization of different units, but there is a limit to it. So we'll see that in another case study coming up. The better projects, it's not an all or nothing approach. You can take a hybrid approach to optimize each project. The funding sources as well for modular construction or offsite construction can be more difficult to secure because you're not giving the bank what it's asking for, which is a project on site until it's actually delivered. So there's complications, and I'm sure there's all types of contracts you need to sign to say that that project will be delivered and not held in the warehouse. So there are some complications to it, but the industry is definitely working through some of these hurdles. So now let's look at a project that had a few complications with execution, shall we say. The 461 Dean Street is a 32-story building that includes 363 apartments and ground floor retail space. The down cycle of the economy in 2008 and pricing with local labor unions led the developer to the modular construction method. The goal was to reduce the cost by 20% and shorten the schedule from 30 months to 10. So if you're familiar with modular scheduling or offsite construction scheduling, that seems optimistic. 30 months to 10 can be done with proper coordination. But this building contained 930 steel framed modules arranged around a double loaded central corridor. The desire for customization resulted in 225 unique module types, including the elevator core and stairwells. Each of the project's prefabricated curtain wall panels includes a compression gasket around its perimeter that forms a seal with adjacent modules. Sounds good, right? These were installed these seals were installed on the modules off-site, which is not typical due to limited adjustability when you get on-site. The contractor had a little difficulty controlling the geometry of the modules during the handling, and a number had to be readjusted on-site. So that had added a layer of complication with waterproofing. The project suffered significant delays due to the inability of the manufacturer to produce modules as quickly as required to keep up with the crane on site. So they couldn't build them fast enough to stack them. So some modules had to be gutted and renovated on site because the water damage caused by improper detailing of the temporary roof membrane on the lower level modules allowed water into the building interiors. So once the lawsuits are settled, the developer took control of the off-site fabrication operation and hired a different contractor to oversee the on-site work. So in addition, the development team underestimated the time required to set up the fabrication facility, train the workers, and establish a reliable supply chain for a new off-site manufacturing facility with a GC lacking modular experience. Ultimately, instead of 10 months, it took 4 years to top out the project. So this one, you know, it doesn't really say whether or not they met their pricing goals, but I would assume not, based on the extended time it took to complete the project. And there were just other factors into this one. You know, all the red flags seem to pop up. Unique module types, I mean, too many of them. You also had labor unions involved, which wanted to participate in the process. And then whenever litigation gets involved, things get stretched out. So let's finish out with some additional considerations for designers in particular. The ideal modular project has components that can be built better, faster, and more cost effectively in a factory environment rather than on site. It's simply a matter of scale. How much of each project should be factory built? The most important effect on designers on the design process is to analyze the project and decide early on in the process with all the stakeholders involved and everyone informed as to the pros and cons of the different approaches. This is important because there can only be limited changes when the building goes into production. Again, back to manufacturing. Manufacturing is the driver in this type of production method. Changes are very difficult and expensive at that point and can't be applied to all the units. So ideally, programming in schematic design will indicate the best direction of the project. If not, design development is the last phase to be considering the change without significant redesign and expense. So engagement in a process is key. The design build process does not have sufficient feedback mechanisms to get the right information to the right people at the right time, and encourages waste. There's a formality to the design bid build process which stretches out the time schedule and doesn't get the proper sharing of information, formalizes that process, which does not lead to the optimal outcomes, shall we say. The optimal delivery mechanism is integrated project delivery, or IPD. This opens up collaboration during the design process and encourages the flow of information between the team members. Including a manufacturer in this feedback loop is best practice. So get all the information from all the elements. Now, whether or not it's the IP, number 3 or number 4 there, IPD on the top, where it's a flow of information between the 3 elements, 3 stakeholders, or if it's the hybrid process, which is actually pulling in more information from, let's say, a manufacturer, not a subcontractor, and then the contractor's engineers and clients and consultants. So just getting that information flow correct so you get the right information at the right time is key. Integrated project delivery is actually based on the principles of lean construction or lean production methods, producing the right product at the right time and the right quality for the customer. This method actually originated with Henry Ford and his famous Model T and was refined into the Toyota production system by Taiichi Ohno. Taiichi Ohno added another level to this. Henry Ford was, I guess, famously rigid in his approach. He was all about reducing waste and increasing efficiency, whereas Toyota allowed for variability of manufacturing in that process. So again, back to the manufacturing element, the manufacturing allowing for a little bit of flexibility in what you can create, did add a different element or different angle to the lean method. So not to overstate it, it's simply a manufacturing sort of ideology or methodology but it is producing the right product at the right time and the right quality for the customer and exactly what you need and nothing more. So it's a good goal, but let's see how it dialogues with the construction process. Lean construction is a design and execution methodology to minimize waste of material and effort in order to generate maximum value. So it really reduces the amount of waste in generating the maximum value for the building owner. Offsite construction actually takes this methodology one step further, which kind of leads back to its original origins in manufacturing. Lean design, once you take that sort of extract it for design, I mean, the principles apply. It's not a manufacturing, of course, process when you're working in design, but it is a process that will reduce waste and rework by getting the right information to the right people at the right time to make the best decisions for their client and the project. So ultimately, the building is built and must pass code inspections. These are generally less onerous because they don't shut down the project until they pass. They can be handled by third-party inspectors and on-site after delivery and assembly of modules. The states generally get involved, as well as can be the local authorities with jurisdiction, but it all must comply with the codes applied to the site. But there are different, if you have let's say a state like Colorado, you may simply need to meet state requirements in order to meet the codes on site. So definitely check on which codes you need to meet. They all lead to the same quality of good quality of construction, and everyone wants the project to be built to the applicable code for the site. So Johns Manville has developed multiple assembly solutions for offsite construction using our exterior envelope materials, our continuous insulation materials. Each of these assemblies has undergone rigorous testing for racking strength, water, air, vapor intrusion, and fire and acoustics. Our latest polyiso sheathing assembly has passed NFPA 285 with ACM metal panels, the most difficult panel to pass with, which does allow a full range of materials to be used for cladding systems on your projects. I will pass it back to Jerry for additional resources and to take us home.
Sounds good. Thanks, Dwight. Just to look at a couple of additional resources. These additional resources are available online, and you can see the construction process through organizations such as the Modular Building Institute, Modular Home Builders Association, National Association of Home Builders, and Modular Mobilization Coalition. All of these organizations have a little different focus on the industry and can help guide you to experienced partners in this growing field. Each one of these is an incredible resource. As a matter of fact, we're members of most of these organizations, and we partner up with them to assist their clientele and their folks who basically lean on them for assistance. One thing about the modular building industry, what I found, which is extremely unique, is that even though you may be building with one specific factory, it's interesting, they tend to all work together because they all want to be successful in the building industry. And so it's a very family-oriented feeling when it comes to these organizations. They do like to share information. So it's always good to get multiple opinions, but you'll see that they all kind of work together to coordinate to make sure that the entire industry is successful, not just one specific company. So I think that's a unique approach, but it's definitely helpful. When it comes to Johns Manville, as Dwight just mentioned, we have determined a number of different assemblies using our product lines, and currently we have the largest portfolio of building insulation products in the United States. We manufacture everything from fiberglass, mineral wool, blown-in fiberglass materials, spray foams, and polyiso boards, as well as some specialty products like Go Board, which is a polyiso tile backer board. What gives us an incredible advantage here is that we have the capabilities of creating these hybrid type systems. We understand that not one particular product line fits every need for every person in every situation, but we have the unique ability to be able to create those assemblies that Dwight just mentioned, utilizing, a combination of materials, or one material may complement another material, so that we have a vast selection of solutions. So I believe now I'm going to turn it back over to Natalie and let her finish us off.
Yeah, thank you both. Before we get into some questions, I'd like to take a few minutes to go through some additional resources we have for you guys. We maintain all of our informational resources on an online portal called The Source. This is where you'll have free access to our recorded webinars, such as this one, blogs, product documents, trainings, and tools. Also, if you don't already, I encourage you all to follow us on social. We have the Building Insulation LinkedIn page, YouTube channel, and Insulation Intel Twitter. Also, for anyone who attended today, you will receive a certificate of completion after the webinar that may be submitted for professional development hours. This will be sent to you via email and should be in your inbox by next week. If you haven't already, please take a look in the chat box or scan this QR code again and take a moment to register for the AIA certificate. Again, a recording of this webinar will be posted on The Source within the next couple of days. When it becomes live, we'll also send you a link for direct access. So if you missed any part of the presentation today, if you would like to view the webinar a second time, you'll be able to access it on demand. And with that, let's take it into some questions. I'm just going to open these up to our panelists, so Dwight and Jerry, if you'd like to take them as they come. Let's start with, what indicates the optimum approach to be panelized versus volumetric modular construction?
I'll take that one. Yeah, I'll take that one. Interesting that one's brought up. There are going to be great opportunities for both of these construction methods. If you think about it, they both have their limitations, but they also both have their advantages. If we're looking at a volumetric modular building, the advantage, obviously, like we mentioned in the presentation, is you're going to have a more complete unit that can be assembled in a factory, shipped to the site, hoisted in place, and then mended together with minimal construction time, if you will. And you're going to have a quicker dry-in time as well. So that's going to be a great opportunity. I would say that in some cases, some of the limitations may be height of your building, or maybe the site constraints that you may be facing. So you have to analyze the entire project in order to understand which system works best for your project. The panelized systems have great advantages as well. And if you think about it, a lot of times you will see a shell of a building being constructed and erected on a building site. And then the offsite construction panelized companies could be at the same time building the panels that then become hoisted in and set in place, so that you can have a fast time of completing the building and drying it in. So it just depends. I mean, it may be a little more difficult to hoist an entire volumetric portion of a building up 19 stories, but it'll be a lot easier to do that with a panelized system. So both have their advantages, and they're both, both designed to speed up the construction process. And I think they both do a great job of achieving in their own ways.
All right, thank you, Jerry. Next, we have, does the general contractor need to have any special certification to oversee modular construction?
Oh, that's a good question. So to my knowledge, it's really an experience category. So you have GCs that are designed that really have the experience of working on site. That's what they do. They do it very well. And they may open their own shop to do some prefabrication, but more in the smaller scale elements. Then there are, you'll see on the MBI website, there are GCs that specialize in the, putting together of the building. So they'll handle some portion of the logistics, the site logistics once the trucks get there. The staging of the modular, the volumetric units if necessary, and then the assembly on site. So that's their specialty. That's what they do. In terms of folks that do both, I'm sure they're out there, but really it is more of a specialized approach. So you'll find that GCs sort of separate themselves based on their specialization. Jerry, anything to add on that one?
Yeah, I mean, I think that we consider general contractors to be kind of the do-it-all kind of folks, right? They organize the entire process of a building being built, and that's what they do best. The experience part will really play a huge role in this particular situation, simply because the coordination, it may just be a little different mindset on the coordination side. And I agree with what Dwight's already mentioned. But he's going to have to, the general contractor will have to coordinate the, like Dwight said, the delivery, but also the setup. And in the meantime, it's a shortened construction schedule because they're basically attending to the foundation. And then once the delivery is made, the units will be in place, and then they have to finish the units. So it's just a little different thought process. Ultimately, they're building a building, yes, but there's different steps in the process. And I think that goes back to what Dwight was saying on the experience part. And I think that, again, the Modular Building Institute has a great resource for that. So hopefully that helps.
All right, thank you both. We did just have one come in. I know of a modular project where roofing insulation is already being installed prior to being in place. Does modular roofing take into consideration thermal breaks?
I guess either one of us could answer that because we both worked in roofing, but the answer to that is yes. If they are under standard circumstances, and I'm going to say standard, simply because if the roof will not be completely finished, if you will, and where the units go together, we call a mend line. And at that mend line, there would typically, we would recommend typically, there'd be 2 layers of insulation. That mend line would have possibly a roofing material already applied to a certain portion, to a certain point, and then the adjacent part of the building being set in place will then allow that mend to occur where you can overlap the missing pieces, if you will, of insulation before you finish the roof itself. So the roof definitely, and the building insulation, especially if it's polyiso boards, we always recommend that you have 2 layers and that they cover over the first layer is down and offsets for the second layer to cover over the actual intersections of the insulation. So in my mind, for commercial buildings, that gives that opportunity. It should yield itself.
Yeah, one of the requirements that as a roofing manufacturer, sort of guiding installation, is that you never have more than a 1/4 inch gap. So I would assume if those gaps occur when the assembly is being put together on site, even if it's fully complete roofing system, they're just laying over the flap and of the TPO and welding it, they would no doubt fill that gap, or at least they would be required to fill that gap in order to get a warranty with Johns Manville and most other manufacturers. If they do it the way Jerry spoke of, they'll actually hold back the installation, and they will get that offset installation of that top layer, which is really kind of key to reducing the thermal breaks in that application too. So just depends on how far they're taking it and what that finishing piece is, but ideally that thermal break would be filled.
Okay, thank you. Next is kind of a two-in-one. What is it about the European construction industry that has embraced modular construction so much more than the U.S.? What makes the idea of offsite so much more appealing there, and why is the growth and adoption so much slower in the U.S.?
I've got some stats there I can throw in.
Yeah, I'll let you start, and then I'll come back. How about
there
that?
you go. You do it. So Europe overall, and this may be driven by the types of construction that's going on, but they have basically a 30% offsite construction component. So if you want to guess the country with the most offsite construction, that's actually Sweden, and it's about 80% of their construction is done offsite. I have not identified the key to why each country has adopted it more often than others. However, Sweden is the source of IKEA, I just have to say. So to walk through the manufacturer and choose your model, I guess. But it might have a lot to do with the type of construction that's being done, because different types of building programs lend themselves to offsite more than others. And also due to the how close the where buildings are being built. Do you want to be constructing on site, having lots of laborers making lots of noise in this middle of Paris, or do you want to just boom it into place and be done with it in a couple of days or a week, which has much less impact on the environment it's in. Jerry?
Yep. I mean, that's a great answer, Dwight. What I would add to that is that lifestyle are completely different. We have in America, we have a completely different lifestyle, different outlook on what a home should be. I mean, I think that if you look at our average home size in America, our ranch style homes or single family homes, 3,000, 2,500 square feet, right? Where if you look at the European models, they're just a portion of that. They don't necessarily see that they need to have larger spaces. And so it becomes more economical, more compact, even their appliances and how just their entire lifestyle in general. So it's a faster adaptability. And even if you look at the materials, sometimes they don't necessarily focus on the price or cost of all of their materials. They sometimes would rather put a higher grade material in place rather than save a dime today and spend it tomorrow to replace it. So it's a different outlook. I think we are heading in that direction. I think as far as looking at a way to resolve some of the issues that we're facing and with our lack of ability or lack of availability of homes and affordable homes. And there are many companies that we see through the offsite industries who constantly are evolving ways to figure that out. So I think we're going to have to make a change in the United States. Again, with that labor shortage and with the number of skilled workers that are leaving the construction force, is going to force our hand into figuring out a better way to build or a different way to build to keep up with the demand of what we're needing to meet. So I hope that helps to shine a light on differences.
Okay, it looks like we have time for just about one more question. Let's lastly ask, are there documents developed for evaluation of an offsite approach? If so, what are some examples?
Documents, I'm going to make a little bit of an assumption here. I'm assuming that they're referring to either inspection documents, so they could be referring to construction documents, but I'm assuming they're referring to construction documents, just as a quick answer. There are guidelines that I think that the industry has learned over time, and again, that evolves around just the process of transportation. I think transportation is the huge limit to how large of a unit can I create and transport to a site. Dwight mentioned it in the presentation. Again, the width and the height of a unit is typically what limits us in our size that we can manufacture. The length is a little more flexible. I mean, you can transport longer items, just the wider and taller items are a little more difficult. But the guidelines, I think, are the limitations around transportation as a quick answer as we kind of hit the top of the hour.
Yeah, working on another angle of that one, there are, if you're talking in terms of design documents, there are some that have been developed by, let's say, and shared online in terms of, what is included in design development, what are the expectations along those lines, even documents around financing of the project and, what is the pay schedule and things like that. So definitely something to check with the manufacturer. May have their own documents. Definitely they'll have their own contracts. But in terms of protecting yourself in the design field, there are some documents being developed by AIA, and there are some offsite focused designers that are sharing some of their documents online. One of them is actually EV Studio, so they've developed some guidelines for design documentation there too.
Okay, great. Thanks, guys. And thank you very much to everyone who attended today. If you have any additional questions, please don't hesitate to reach out to us directly or via the survey that will pop up on your screen directly after the webinar. Otherwise, take care and enjoy the rest of your week.